Welcome to the talk on preparing for the 21st century existential risks. I'm David Lepore, work at Argonne National Lab near Chicago. Uh, the outline will go over our current situation, kind of an inflection a period of a lot of change from a very long-term singularity trend. Go over that a little bit. Then what risks might occur during this period, what could be done to reduce those risks, what trends might be used to generate or develop scenarios, and then what it would maybe look like based on what other people and other organizations are pursuing. So first, we take a look at a book that was just published in January of this year. Andrei Korolev and myself are co-editors of it. About half of the chapter authors are from Russia, a few from the US, including myself, some from Europe, some three from Australia, and one from India. In there, we look at kind of this long-term trend of how things speeding up as we go through the Big Bang to life evolution, human evolution, civilization. And it looks like things speeding up in kind of a trend towards a hyperbolic kind of singularity. But it's not going to be hitting that singularity. The limits are going to occur, which cause the rate of change to slow down a little bit. And so kind of we might be at this particular inflection point here, a very large change from speeding up maybe to a possible slowing down. It's a very large change. Another way to look at this particular period is to compare it to sending a rocket into orbit. And so I like to say that this rocket has all its fuel it needs to get into orbit. Once it's in orbit, it does not need any fuel to kind of keep it going. And it's moved from one stable state into an elevated state in the orbit. Similarly, we're moving from an agricultural society of farming into an advanced sustainable society, sustainable energy and materials. And the way we do that transition is to use our finite amount of fossil fuels. Hopefully we use that in a way that's beneficial so that we can arrive at a sustainable way of using energy and materials later. So with these, some of the inflection characteristics now is that change is relatively fast, almost as fast as it might be. Anytime things change fast, accelerates, it leads to many stresses, right? So with stress, things break, are put under the highest test, including looking at global limits, which are now encountered. A lot of them lead to nonlinear interconnected problems that arise. Right now, we're kind of seeing one in the pandemic, kind of a global issue. That started very small and rose quite quickly. And still, we're trying to look for solutions to it. So there is a potential that might slow down. So this is kind of a path, a bifurcation path. As some parameters increase, the complex adaptive system, meaning the learning system, kind of splits, and the splits become faster and faster. A regular complex adaptive system, if that driving parameter increases too much, it goes into chaos. And that's really not what we want. And so some of them with limits, it's been shown, goes into a reversal state. That is, it goes here, it inflects, it then becomes simpler on forward before and not going into the chaotic state. So that's one thing that we want to hopefully avoid. So that potential slowdown might be very different than business as usual as we undergo changes in energy, the environment, and demographics, both in number and the quality of life. So what are some of the risks that are out there? So we have environmental conditions, water, food, and climate, new diseases spreading, you gotta know that. We have technological conditions, so disruptive technology coming quickly, being implemented quickly, maybe too quickly that we're not really sure how it behaves under all conditions. So we have a strong dependence on cyber type of technologies, where the bio kits are becoming more and more available, very powerful. And it does seem like energy is a key to many of these issues, as others have pointed out. But we're also undergoing this energy transition from fossil fuels, which is causing some of the potential climate change, and transitioning to renewable. So the changes and uncertainties could lead to risky decisions, either with proper handling of wicked problems that has many options, many stakeholders, and nonlinearity. The problems are very tough to begin with to solve. Maybe handling information with uncertainty. All the information is not fixed. And then we have intentional problems, terrorism, and so on. Uncontrolled technology in terms of disrupting, not knowing how it will fit in, and then also just plain mistakes that come in there. And so kind of showing the Earth on the edge, and this is from the Bulletin of Atomic Scientists, which is kind of headquartered at the University of Chicago, which is tied to Argonne in Chicago. So what could be done? How would we address some of these risks? So one is to look at the wicked problem process. And so I have some of the characteristics on the side here of wicked problems. So you usually cannot solve directly. You need to try to monitor and adjust. You can't really say that this is a solution and then implement it. You have to keep on monitoring it. Sometimes it's not reversible. You just have one try to it. Within that process, we could use some trends to kind of construct some scenarios, right? We're not exactly sure what the future is going to be. It's kind of based on how we behave and what we do. But we have some trends to kind of set the envelope as to what possible scenarios might be out there. So set an envelope, bounding conditions on the scenarios. And then monitor and assess the path so that we can refine the scenarios and assign them probabilities kind of in a Bayesian way. This would have to be done kind of on a collaborative international way because a lot of these problems are global due to the limits. And so monitoring them, assessing what's going on when things are tried, and then collaborating on revision. So assessing the experiments are kind of like now with the virus, people try different social openings of the economy to try to see what works without having loss of the infection. So what are some of the trends? I just show them here. There's more in the write-up. One is energy trend. There is type by the waves of coal, oil, gas, the efficiency and renewable coming up. There's a carbon to hydrogen ratio. There's demographics. Andrei Karatev showed this in a recent paper, kind of the correlation between population growth and economic gap. In the environment, one showing the levels of environmental actions, kind of the waves of them, each wave kind of taking longer to resolve but coming sooner. There's various learning curves for renewables, that is, the cost goes down as the experience increases. There's power laws that will generate based on some type of events. So, for example, I looked at one for weapons of mass destruction to find out how probable some things might be when you put all the probabilities together. And then also the scenarios, developing the scenarios based on the singularity, the inflection, try to avoid chaos, try to look at what happens as the business as usual, kind of within the envelope of these trends. So what would it look like? What we'd want to have is some monitoring and assessing of the past. So identify the trends, update them, have some real options analysis to look at potential paths, include the uncertainty in there, have groupware decisions because there's many stakeholders, and then hopefully have some model assessments of them. And so one way is agent-based modeling, which we currently are doing at Argonne kind of for this COVID modeling for the city of Chicago. So some of the organizations out there, Stockholm Resilience Center, which has these planetary boundaries that can be measured. The idea is that there's enough impact on the Earth and some of the boundaries for the Earth systems to kind of recover or be resilient might be gone over, and something would have to be done with it. There's also the Millennium Project, which has a set of nodes already throughout the world, kind of headquartered Washington, D.C. By Glenn. Then also various things, for example, the University of Cambridge, the Center for Study of Existential Risk. Just want to make one comment. I've been involved with one way where Russia and the U.S. came together to kind of mitigate one of the risks before, and that is the recycling of nuclear warheads into electricity. This was a very successful program between the U.S. and Russia. It lasted for about 20 years, from 1993 to 2003. I was involved in that, monitoring things in Russia, and it was very interesting, nice time for me to take a look at that, and we had a very good trip. So the conclusion is that this is a very complex period in human history. It's fast, uncertain. We have a question of technology control or disruption. There's global limits, and we're also undergoing an energy transition at the same time. There's various risks in the environment and the technology and misinformed decisions when the decisions become very tough. We could collaborate on global issues, addressing these wicked problems, realizing that the problems are very difficult and can't just be solved once, but we have to try things and go back and revise them and assess them, continually assess them. And we could develop scenarios based on these trends, then monitor, assess, and revise. And there are many institutions out there laying a path. Thank you very much for coming here for or listening to this presentation. My email is on the beginning, dlapour@anl.gov. Please let me know any comments, questions, or concerns. Thank you very much. Bye.